In this unit, we will learn about data visualization and how to effectively represent data using plots and charts. We will begin with the basics of Matplotlib, including creating plots, subplots, and customizing elements such as axes, labels, legends, and annotations. We will also explore how to save and style plots along with using the Seaborn library for enhanced visualization. Further, we will study advanced visualization techniques such as scatter plots, line plots, bar charts, histograms, box plots, and pair plots to analyze data patterns. Finally, we will look at improving the appearance of plots and understand 3D visualization techniques like surface plots to represent complex data in a more intuitive way. Matplotlib is a powerful and versatile open source plotting library in Python that is widely used for visualizing data in various formats. It was developed by John D. Hunter in 2003 and provides an easy way to convert raw data into meaningful graphical representation, making analysis and interpretation more intuitive. With Matplotlib, users can create wide range of plots like line charts, bar graphs, histograms, and more, helping transform complex or boring data to clear and interactive visuals. It is highly extensible, meaning it can be integrated with other libraries like Seaborn and Pandas, and also supports additional toolkits for specialized tasks such as geographical plotting. Matplotlib is a cross platform, allowing it to run on different operating systems, including Windows, Mac OS, and Linux. Additionally, it supports interactive plotting features through widgets and event handling, enabling users to explore and analyze data dynamically. Matplotlib can be easily installed using pip, which is the Python package manager. To install it, you need to open the command prompt or terminal and type the command pip install matplotlib, which downloads and installs the library along with its dependencies. After installation, it is important to verify whether matplotlib has been installed correctly. This can be done by importing the library in Python and checking its version using matplotlib library. If the installation is successful, it will display the installed version number such as 3.1.1. This verification step ensures that the library is ready to be used for creating visualizations. To use PyPlot in Matplotlib, a series of simple steps are followed to create and display visualizations. First, the matplotlib.pyplot module is imported, usually with the alias plt, which provides all the plotting functions. Next, the data to be visualized is prepared, typically in the form of lists or arrays. The plot is then created using functions like plt.plot, which generates the desired graph. After plotting, the visualization can be customized by adding a title, axis label, and other elements using functions such as plt.title, plt.xlabel, and plt.ylabel, making the graph more intuitive and readable. Finally, the plot is displayed using plt.show, which renders the visualization on the screen for analysis. In Matplotlib, a plot is composed of several important components that work together to create a complete visualization. The figure acts as the overall container or canvas that holds all the elements of the plot. Within the figure, there are axes, which are the actual areas where data is displayed, and a single figure can contain multiple axes for different plots. Each axis refers to the x-axis and y-axis, which define the scale, limits, stick positions, and labels used to interpret the data. Lines and markers are used to represent the data visually, where lines connect data points to show trends and markers highlight individual data points. Additionally, titles and labels play a crucial role in providing context and clarity, with the title describing the overall purpose of the plot and the axis labels indicating what each axis represents. In Matplotlib, the plot function is used to visualize data by plotting points on a graph. By default, this function not only marks the points but also connects them with lines, forming a line graph. The plot function requires two main parameters. first parameter represents the values on the x-axis and the second parameter represents the corresponding values on the y-axis. These values are typically provided in the form of arrays or lists. Each pair of x and y values represents a point on the graph. For example, to draw a line between 2 points such as 1, 3 and 8, 10, we pass the arrays 1, 8 for the x-axis and 3, 10 for the y-axis. This results in a line connecting the specific points, making it easier to visualize relationships or trends in the data. This code demonstrates how to plot individual points using matplotlib and numpy. Firstly, the required libraries are imported, where matplotlib.pyplot is used for plotting and numpy is used to create arrays for data storage. The x points array contains x-axis values and the y point arrays contain the corresponding y-axis values, representing 2 points 1, 3 and 8, 10. The plot function is then used to display these points, and the parameter O specifies that only markers should be shown instead of connecting the points within a line. Finally, the show function is called to display the plot on the screen. This example highlights how specific data points can be visualized clearly without drawing lines between them. This example demonstrates two different ways of plotting data using matplotlib. In the first part, both the x-axis and y-axis values are provided using numpy arrays. The x-point arrays contain the x-coordinates and the y-point array contains the corresponding y-coordinates. The plot function connects these points in a sequence, forming a line that moves from 1 to 3 to 2 to 8 and then to 6 to 6, 1 and finally to 8, 10. This shows that multiple points can be connected to visualize trends or patterns. In the second part, only the y point array is provided and no explicit x values are given. In this case, matplotlib automatically assigns default x values starting from 0 and increments by 1 for each point. As a result, the y values are plotted against their index positions, creating a line graph without explicitly specifying the x-axis data. The example in this slide demonstrates how to customize marker in the plot using matplotlib. The first part, the y point arrays is created and the plot function is used with the parameter marker equal to O, which places a circular marker at each data point on the graph. This clearly helps in identifying individual values in the plot. In the second part, the size of these markers is increased by using the parameter ms, which stands for marker size. By setting ms to 20, marker becomes larger and more visually prominent. These customization options improve the readability and appearance of the plot, making it easier to interpret the data points. Format strings in matplotlib provides a concise way to define the appearance of a plot using a single parameter called FMT. This format string combines three elements: marker style, line style, and color written together in the form of marker line color. For example, a format string like O is to R represents circular markers, a dotted line, and red color. Instead of specifying each property separately, this shortcut makes the code simpler and more readable. Different line styles such as solid, dotted, dashed, and dash dot can be used to distinguish between data patterns. Additionally, further customization can be applied using parameters like marker size and marker edge color to enhance the visual appeal. Overall, format strings help in quickly styling plots while maintaining clarity and flexibility. In Matplot, the appearance of the lines in a plot can be customized using properties such as line style and color. The line style parameter, also written as ls, is used to define the pattern of the line such as solid, dotted, dashed, or dash dot. For example, setting line style to dotted creates a line made of small dots, while dashed produces a broken line pattern. These styles help differentiate between multiple datasets in a single plot. Similarly, the color of the line can be specified using the color parameter or its southhand C. Colors can be defined using short codes like R for red, blue for blue, and G for green. By adjusting the line colors and styles, plots become more visually clear organized and easier to interpret. In Matplotlib, the thickness of a line can be adjusted using the line width parameter, also written as LW. This parameter takes a floating point value that represents the width of the line in points, allowing the user to make the line thinner or thicker based on visualization needs. For example, setting a higher line width value such as 20.5 results in a bold and prominent line, which helps highlight important trends in the data. Additionally, Matplotlib allows plotting multiple lines on the same graph by simply calling the plot function multiple times with the different datasets. Each line can represent different data and can be customized individually using colors, styles, and widths. This feature is especially useful for comparing multiple datasets within a single visualization, making the analysis more effective and visually clear. The code in this slide demonstrates how to plot two lines on the same graph using Matplotlib. First, the required libraries are imported, where matplotlib.pyplot is used for plotting and numpy is used to create arrays for storing data. Two sets of data are then defined, x1 and y1, that represents x and y coordinates for the first line, while x2 and y2 represent the coordinates for the second line. The plot function is used to draw both lines in a single statement by passing the x and y values of each line as arguments. This results in two separate lines being displayed on the same graph, allowing easy comparison between the two datasets. Finally, the show function is called to display the plot. This approach is useful when visualizing multiple relationships or trends within the same figure. This code demonstrates how to add labels to the x-axis and y-axis in Matplotlib plot to improve clarity and understanding. First, NumPy and Matplotlib are imported and the two arrays x and y are created to represent the data values. The plot function is used to draw a line and graph connecting the corresponding x and y points. To make the graph more intuitive, the xLabel function is used to label the x-axis as average pulse and the ylabel function is used to label the y-axis as calorie burnage. These labels help the viewer understand what each axis represents. Finally, the show function is called to display the plot. Adding axis labels is an important step in making visualization clear, meaningful, and easy to interpret. The code in this slide demonstrates how to add a title along with axis labels to a plot using Matplotlib. First, NumPy and Matplotlib libraries are imported and the data for x and y values is defined using arrays. The plot function is used to create a line graph based on these values. The title function is then used to add a descriptive title, sports watch data, which provides context for the visualization. Additionally, the x-label and y-label functions are used to label the x-axis as average pulse and y-axis as calorie burnage respectively. These labels help in clearly understanding what each axis represents. Finally, the show function is called to display the complete plot. Adding titles and labels enhances the readability and effectiveness of the visualization. This code demonstrates how to customize the appearance of text in a Matplotlib by setting font properties for the title and axis labels. First, NumPy and Matplotlib are imported and the data for the x and y axis is defined using arrays. Two dictionaries, font1 and font2, are created to specify font properties such as font family, color, and size. The title function uses font1 to display the title, sports watch data, in a larger size and blue color, making it more prominent. The X-label and Y-label functions use font2 to style the axis labels with a different color and slightly smaller size. The plot function is then used to draw the graph, and finally the show function displays the style plot. This customization improves the visual appeal and readability of the graph by making important text elements stand out clearly. This code demonstrates how to change the position of the title in a Matplotlib plot. After importing the necessary libraries and defining the x and y data using NumPy arrays, the plot function is used to create a line graph. The title function is then used to set the title as sports watch data, and the parameter lock is specified as left, which positions the titles on the left side of the plot instead of the default center alignment. The x-axis and y-label functions are used to label the x-axis and y-axis for better clarity. Finally, the show function is called to display the plot. Adjusting the title position helps in improving the layout and presentation of the visualization based on user preference. This code in the slide demonstrates how to add grid lines to a matplotlib plot to improve the readability. After importing the required libraries and defining the x and y data using NumPy arrays, a line graph is created using the plot function. The title and axis labels are added to provide context and clarity. The grid function is then used to display the grid lines on the plot, which helps in better visual alignment of data points and makes it easier to interpret values along the axis. Finally, the show function is called to display the complete plot. Adding grid lines enhances the overall visualization by making the graph more structured and easier to analyze. This code uses several matplotlib functions to create and customize a plot. The plt.plot function is used to draw the line graph using the given x and y values. The plt.title function sets the title of the plot, while plt.xlabel and plt.ylabel are used to label the x-axis and y-axis respectively, providing context to the data. The main customization in this code is done using the plt.grid function, where the parameter axis is set to x, which means grid lines are displayed only along the x-axis and not the y-axis. Finally, the plt.show function is used to display the complete plot. The code uses several important functions from NumPy and Matplotlib to generate and plot data. The np.arange function is used to create a sequence of values from 0 to 10 with a step size of 0.1, which serves as the x-axis data. The np.sign function computes the sign values for each of these x values, generating the corresponding y-axis data. The plt.plot function is then used to plot the sine curve, and the color parameter is set to blue to customize its appearance. Finally, the plt.show function is used to display the plotted graph. These functions together help in generating mathematical data and visualize it effectively. This slide uses key functions from NumPy and Matplotlib to generate and customize a plot. The np.arange function is used to create evenly spaced values between 0 and 10 with a step size of 0.1, which forms the data points. The np.sign function computes the sign values for these points. The plt.plot function is used to draw the graph of the sign values, and the color parameter sets the color to blue. The main customization is done using the plt.xlim function, which sets the range of the x-axis from 0 to 60, controlling how much of the graph is displayed along the horizontal axis. Finally, the plot.show function is used to display the plot. This code shows how we can customize ticks and ticks labels in a plot to make it more understandable. First, we generate some data using NumPy and plot it using plt.plot. Then, instead of using the default numeric ticks, we used plt.xticks to manually set the position on the x-axis and give them custom names like 0, 2, 4, and so on. Similarly, plt.ytick is used to set labels like min, 0, and max for the y-axis. This makes the graph more intuitive and easier to read, especially for presentation purposes. Finally, we add a title using plt.title and display the plot using plt.show. So overall, customizing ticks and labels helps in making the visualization clearer and more meaningful. Ticks and tick labels are customized using Matplotlib's object-oriented approach. First, a figure and axis are created using plot.subplots and the data is plotted using ax.plot. Instead of relying on default tick values, specific positions on the x-axis and y-axis are set using ax.set underscore xticks and ax.set underscore yticks. Then these numeric values are replaced with meaningful text labels using ax.set underscore xtick labels and ax.set underscore ytick labels such as 0, 2, minimum and max. This improves the clarity of the graph and makes it easier to understand. Finally, plt.show is used to display the plot. This code demonstrates how to use a legend in a matplotlib plot to describe and differentiate data. First, data for the x-axis and y-axis is defined and the plot is created using plt.plot. The plt.legend function is then used to add a label to the plotted line, in this case single element which appears in the legend box. This helps in identifying what the plotted data represents, especially when multiple lines are present in the same graph. The position of the legend can also be adjusted using the lock parameter, although by default it is placed in the best possible location. Finally, plt.show is used to display the plot. Using legends make the visualization more informative and easier to interpret. This example shows how to customize and use labels effectively in matplotlib. The plot.legend function is used to display labels for different lines in a plot, making it easier to distinguish between multiple datasets. The position of the legend can be controlled using the lock parameter, such as placing it at lower right or lower left of the plot. When plotting multiple lines, labels can be assigned directly within the plot function using the label parameter, and then all labels are displayed together by calling legend. In the sine and cosine example, both functions are plotted on the same graph with different styles and colors, and the legend clearly identifies each curve. This helps in comparing multiple datasets within a single visualization and improves the overall clarity of the graph. The code in this slide demonstrates how to plot multiple lines and customize the legend position in matplotlib. First, the data for two lines is defined where y1 and y2 represent different sets of values. The plt.plot function is used twice to draw both lines, and each line is given a label using the label parameter, which will be displayed in the legend. The plt.legend function is then used to show the legend, and the parameter bbox to anchor is used to position the legend at a custom location outside or above the plot area. The endCall parameter specifies that the legend should be displayed in two columns, making it more organized when multiple labels are present. Finally, the plt.show is used to display the plot. This approach improves readability and allows better control over the placement of the legend. This code demonstrates how to create multiple plots in a single figure using the subplot function in matplotlib. The subplot function is used to divide the figure into a grid layout where the first argument represents number of rows and second represents the number of columns and the third specifies the positions of the current plot. In this example, the figure is divided into one row and two columns. The first subplot is created using subplot of 1, 2, 1, where the first data set is plotted, and the second subplot is created using subplot of 1, 2, 2 for the second data set. This code demonstrates how to draw two plots one above the other using subplot function in matplotlib. The figure is divided into two rows and one column using plt.subplot of 2, 1, index. The first subplot is created with plt.subplot of 2, 1, 1, where the first set of x and y values is plotted. Then a second dataset is defined and plt.subplot of 2, 1, 2 is used to create the second plot below the first one. Each plot is drawn using the plot function and both are displayed together using plt.show. This arrangement is useful when you want to compare two datasets vertically in a single figure. Demonstrates how to create a 2D grid of subplots using matplotlib. The subplot function is used with three arguments where the first value represents the number of rows, the second represents the number of columns, and the third indicates the position of each plot in the grid. In this example, the layout is defined as 2 rows and 3 columns, creating a total of 6 subplots. Different datasets are plotted in each position by repeatedly calling plot.subplot followed by plot.plot. Each subplot is placed in its respective position in the grid, allowing multiple graphs to be displayed in a structured format within a single figure. Finally, plt.show is used to display all the plots together. This approach is useful for visualizing and comparing multiple datasets at once in an organized manner. Annotations in Matplotlib are used to add extra information or highlight important parts of a plot. They usually appear as text or symbols that will help explain specific data points or regions, making the visualization more meaningful. The annotate function allows flexible positioning using different coordinate systems, so text and markers can be placed exactly where it is needed. Text annotations are commonly used to describe or give context to certain values, while marker annotations help highlight important points using symbols. Callouts are another useful type where arrows or lines are used along with text to draw attention to a specific feature in the plot. Overall, annotations make the graph more informative and easier to understand. This code demonstrates how to add a simple text annotation to a plot using Matplotlib. First, a basic line plot is created using the given x and y values with markers added to clearly show each data point. The annotate function is then used to place a text label called simple text annotation on the graph. The xy parameter specifies the point being highlighted, which is 4, 8, while xy text defines where the text should appear slightly above and to the side of that point. Since no arrow properties are provided, only the text is displayed without any correcting arrow. Additional styling options like font size and color are also applied to make the annotation more visible. Finally, the plot is displayed using plot.show. This code demonstrates how to add an annotation with an arrow in a matplotlib plot. First, a line graph is created using the given x and y values with markers to highlight each data point. The annotate function is then used to label a specific point on the graph, in this case the point 3, 5 with the text peak. The xy parameter specifies the exact point being highlighted, while xy text defines where the text should be placed. The arrow props parameter is used to draw an arrow from the text to the point, making it easier to identify the highlighted location. Additional elements like axis labels, titles, and grids are added to improve the readability. Finally, the plot is displayed using plt.show, resulting in a clear and informative annotated visualization. This code demonstrates how to add an annotation with both an arrow and a bounding box around the text in a matplotlib plot. First, a line graph is created using the given x and y values with the markers to clearly show each point. The annotate function is then used to highlight a specific point, in this case 3, 6, with a text with bounding box. The xy parameter defines the point being annotated and xy text sets the position of the text. The BB box parameter is used to draw a box around the text where properties like box style, padding, edge color, and background color can be customized to make the annotation stand out. Additionally, the arrow props parameter is used to draw an arrow from the text to the data point, improving clarity. Finally, plt.show displays the plot. This type of annotation is useful when you want to highlight the important information clearly in a visually appealing way. This slide shows different types of box styles that can be used in annotations to highlight text in a plot. In Matplotlib, the BB box parameter allows us to customize the shape of the box around annotation text. There are several styles available like square, circle, ellipse for simple shapes, and arrow-like styles like arrow, raro, and D arrow for directional emphasis. Rounded styles like round and round 4 give smooth corners, while styles like sawtooth and round tooth add decorative edges. Each box style can be adjusted using parameters like padding to control spacing and other properties like rounding size or tooth size. Choosing the right box style helps to make annotations more visually appealing and improves how information is highlighted in the plot. Saving figures in Matplotlib allows us to export the plots we create into different file formats so that they can be used in reports, presentations, or publications. This is done using savefig function, which saves the current fig to a file. Matplotlib supports several common formats, each suited for different purposes. For example, PNG is widely used for general images and supports transparency, while JPEG is useful for images with smooth color variations but may lose some quality due to compression. PDF is ideal when we need high quality vector graphics that can be scaled without losing clarity, and SVG is also a vector format commonly used for web and interactive graphics. Choosing the appropriate format depends on how and where the plot will be used. The savefig function in Matplotlib is used to save a plot as an image file, and it provides several parameters to control how the figure is saved. The fname parameter specifies the file name or path, and the file extension automatically determines the format such as PNG or PDF. The DPI parameter controls the resolution of the saved image, where higher values result in better quality. The bbox inches parameters is used to define how much of the figure should be saved, and setting it to tight ensures that unnecessary white space is removed. The pad inches parameter adds a small amount of padding around the figure when using tight bounding. The format parameter can be used to explicitly define the file type if needed, and additional customization can be done using other keyword arguments. Overall, these operations help in saving high quality and properly formatted visualizations. Demonstrates how to save a plot as an image file using Matplotlib. First, the x and y data values are defined and plotted using the plt.plot function. Then labels for the x and y axis are added using plt.xlabel and plt.ylabel, and a title is given using plt.title to make the plot more informative. The key function used here is plt.savefig, which saves the created plot to a specified file path, in this case as a PNG image named lineplot.png. This allows the plot to be reused in reports or presentations. Finally, plt.show is used to display the plot on the screen. Thank you.